Today we are covering two lessons, both 97 and 98. But 97 is pretty much something you already know and many of you have already been doing. Advanced substitution is instead of just getting x equals or y equals, you get something else equals. Maybe, and some of you have been doing this, y squared equals. Maybe you have one where if you have that isolated, it's real easy to plug that in for a y squared in the other equation. Or maybe you realize that you could take 3x and somewhere plug that in to the other equation so that you don't have to deal with fractions. So let's do that first. And with this one, if I tried to get y equals or x equals from either of those equations, I'd have some kind of ugly problems with fractions in it, right? And that would be kind of hard. So what I do with this is I look at it and I say, do I have one that is a multiple of the other? Well, 2x and 5x aren't really multiples of each other, but for these two, the 6y is 2 times 3y. And we've used that idea when we've done elimination, multiply the top one by -2 and add the rows together and they cancel out. But if we really want to do it by substitution, what we could do then is we could take this first equation and we could say that means 3y is -1 minus 2x. And this second equation is really 5x plus 2 times 3y equals -7. So if I want to plug my -1 minus 2x in for this 3y, that would be okay to do, and that's advanced substitution. So I'd change this 3y to a -1 minus 2x, and I'd remember that the 6y is really 2 times 3y, so 2 times what I just plugged in, keep the 5x, and keep the -7. And now I would like for you to finish solving for x. Stop when you get to x, and we'll check and make sure we all got that right, but this should be pretty easy for you at this point. Okay, you guys just said you got -5. Let's see if I can catch up to that. 5x minus 2 minus 4x is -7. Did I do that much right? Combine the x's, and I have an x, add 2 to both sides, and I agree with you, -5. Need to finish solving it. We need to get y, so we're going to come back to our original equation here. And do we like 2x plus 3y or 5x plus 7y? Which do we want to use? Okay, either one would work. I also like the smaller numbers. So 2, the x we now know is -5, and plus the 3y is -1. So this is what, a -10? So add 10. 3y is 9. Everybody, what's y? And write our final answer as an ordered pair, -5, 3, and we are finished. So do you get what we're doing with advanced substitution? Because that's the only one I'm planning to do with that. All right, let's move on then. Relationship of numbers. Kind of some contrived problems where the book says, find the number that is this part of the way from here to there. And the way they word it's going to be important. They're going to tell you where to start and which way to go. This one says from 30 to 40. So the from is where we're going to start. And 40 is going to be the last one where we're headed. So if I think about my number line, I'm starting here and I'm going that way to the right. If I go 7/10 of the way, is that more or less than half? That's more. So I better end up somewhere out in here, right? For my answer to make sense. If I end up with 42, is that going to work? What if I end up with 31? That's too close to 30. What if I end up with 27? That's not even in between. So I always want us, when we finish these, to go back and just think, did our answer make sense? We should do that on any kind of problem. Did I answer everything they asked me? Because we've seen quite a few where we find one thing and it's like, oh, that's not what they asked for, but we needed that to figure out what they asked for. Always take just a fraction of a second, look back. Did you answer the question? Does it make sense? So with this one, we want to start at the 30, and we want to add something to that because we realize we're trying to go to the right. So what I want right now is my fraction times basically that total distance. So my fraction is 7/10, and my distance is, how far is it from 30 to 40? So I take 40 minus 30. Oh, they're 10 apart. Does that make sense to you? So I'm looking at 30 plus 7/10 times 10, or 37. And does that make sense? If we start at 30 and we go more than halfway, we go 7/10 of the way towards 40. Does that look about right? You don't have to draw the number line, but you kind of want to think about it. Okay, now I'm going to change the problem just slightly. What if I do 7/10 of the way from 40 to 30? That now means I need to start at 40 and go to 30. So everybody good with we're starting at 40 and we're going back to the left now? Does that much make sense? So I am now starting at the 40, and I am going to take my fraction, which is still 7/10. But now I want this to always be, when I get my distance, it's going to always be my last minus my start. So if I do my last minus my start here, I'm doing the 30, or the 2, minus the 40, and I'm getting a negative number. That negative is what's going to make me go to the left. So it's still plus this because it's now plus a negative. 30 minus 40 is negative 10. 40 plus 7/10 times negative 10 gives us 40 minus 7, or 33. And does that make sense when you think about the number line? If you start at 40 and go to 33, does that look like you've gone 7/10 of the way towards 30? Is anybody with a question then? Okay, my final example is going to be the same idea, but messier numbers. Griff? You're not actually graphing them. I'm just doing that to help us make a visual connection with what it is we're finding. You only have to do the numbers and the arithmetic calculations. No, it depends on the question. Those were two separate problems. But it will either say from 30 to 40, stop, or from 40 to 30. So first, let's write down the formula that we're using. We are taking the number that we're looking for. It is the starting one, so that's the one where they say from, plus f is the fraction, and then the last number, that's the one where it says 2, and if we subtract them, that's the directed distance, meaning positive if we're starting with something on the left and going towards something on the right, but this will give us a negative when we subtract here if we start on the right and go towards the left, because we would be taking the smaller number minus the bigger number. So I'll give you a moment to get that copied down, and then we'll do our final example. Okay, my numbers in that last example were much too easy. So most of the time you're going to have problems that look more like this. So we're going to start off with our formula. The number that we are looking for is equal to our starting number plus our fraction times our distance. And our distance is the last minus the start. So that should be negative if we go to the left, positive if we go to the right. We are starting at what number? 3.5 plus our fraction is an eighth. And then we take the one where we're ending minus the one where we're starting. So 5 and 1/6 minus 3 and 1/2. So this one is going to give me 3.5 plus something positive. So I'm going to be going to the right. Does that make sense? If we start at 3.5 and we go to 5 and a 6, do we need to be going to the right? So far our setup makes sense, and we're going to go on. All right, we have mixed numbers in here, and we've got some adding, subtracting, and multiplying to do. What should we do first, since we have mixed numbers in this? Can you subtract mixed numbers just like they are, Jack? I'm going to need a common denominator, but that's kind of confusing while I've got the mixed numbers in there. Griff? Let's first make them improper fractions, because that's what we have to do to be able to add and subtract most of the time. So 3.5, and we'll talk through this the long way and the shortcut way just to review. 3 is 6/6, right? And a half, so 6/6 and another half is 7/2 altogether. Shortcut way, 3 times the denominator 2 is 6, plus the numerator of 1 is 7/2, plus an 8. And now you guys get to help me. 5 and 1/6, what will that be as an improper fraction, Ethan? Very good, 31/6. Shortcut, 5 times 6 is 30, plus 1 is 31/6, or the 5 is 36, plus 1 more 6 is 31/6. That's a tongue twister to try to say that one. Minus the 3.5 we already figured out is 7/2. Okay, PEMDAS. Do I have parentheses? So I need to simplify inside the parentheses. I need to take 31/6 minus 7/2. What do I have to do that? What do I have to do that subtraction, Jack? Which would need to be what for that parentheses? So what do I do to the 7/2 to make it have a 6? Over 3. So 3/3. So now I have 7/2 plus 1/8 times how much? Leo, what do I get there? Because I've got the 31/6 minus 21/6 is 10/6. Okay, PEMDAS. I simplified inside my parentheses. I don't have any exponents. I have to multiply or divide before I do that addition. So I need to do 1/8 times 10/6. Remind me how to do that, Wyatt. So what do I have? And I could do it that way. Anybody have another idea? And then I'd have to simplify. Anybody have another way of multiplying an 1/8 times 10/6? What do you think on that one? So the 10 and the 8 or the 10 and the 6, either one, because I've got all those even numbers. So divide that by 5, divide that by 2. So what do I have? 5/24 plus the 7/2. Now what do I need as a common denominator, everyone? So what do I have to multiply 7/2 by? So times 12/12. So we are looking at 84/24 plus 5/24 is 89/24. Does that really register very well with your brains? That does not with mine. Because I want to figure out, does that make sense? Is it between the numbers that I started with? So on these problems, I am requiring that you change back to a mixed number. So we need to figure out how many times does 24 go into 89, and then how much is left over. Who can help me with that? How many times will 24 go into 89? I think about hours in the day because I've kind of memorized 24 hours in one day. How many hours in 2 days? 48. How many in 3 days? And then 96. So how many 24s, Yesenia? Well, 4 times 24 would be 96. So that would be too many. What was 3 times 24? Jack, what was 3 times 24? So that's smaller, right? So we've got 3 and some leftovers. So basically we're saying we've got 72 24ths plus how many extra 24ths to make 89? What's 89 minus 72? So the 17. So 3 and 17 24ths would be our correct final answer. And then, like I said, we're just going to go back and look at the problem and think through, does it make sense? 3 and 17 24ths. An eighth of the way, so much less than half. 3 1/2 going towards 5 1/6. So 3 1/2 going towards 5 1/6. And we ended up with 3 and 17 24ths. Is that more than 3 1/2? Is it in between there? Because 12 24ths would have been a half. So yes, this is a little bit farther to the right. So on that level, our answer makes sense. Questions from anybody on this? And we're going to work on homework.